We're looking at using some substitution now in doing some integration. So let's have a look at the first one. We've been given the substitution of using u being 1 minus x for x over 1 minus x squared. Now, we do our substitution. To do our substitution, we're going to need to get an expression for dx. So du would equal dx, or dx would equal minus du. X can be written as 1 minus u as well, because we've got to substitute for x. We've got the 1 minus x. Because it's a definite integral as well, remember we've got to do x is equal to 0, so u would be 1. And when x is equal to a half, what u is equal to a half as well. So doing that substitution, we get the 1 to a half, 1 minus u on u squared, times minus du. So the minus can help change that integral around to go from a half to 1. And notice by doing this substitution, what did look really a bit difficult, 1 minus x over 1 minus x to the power of a half. So now it becomes really easy because our denominator is much simpler. And that's the idea of doing a substitution. To make the denominator a little bit, make it more simple, because you can just do a division into the numerator then, and you can separate your numerator then because it's one term. So we get the 1 on u squared and the 1 minus the 1 on u, so you can see how that's changed, and so that becomes minus 1 on u, and 1 on u integrates the log of u. Do our substitution, we'll put 1 in and put a half in, so it gives us minus 1. Natural log of 1 is going to be 0, and that's going to be minus a half, so we'll minus 1 on a half there, sorry, so that gives us the minus 2. And natural log of a half, well, that's because it's minus natural log of a half, or 2 to the power of minus 1. The negative comes down and gives us positive log of 2. So we get minus 1 plus 2 gives us 1, and minus natural log of 2. So there's how that one is simpler, because we're able to make our denominator simpler by doing that. Here's one where we've got x times the x minus 2 to the power of 5. And so let's do a substitution of x minus 2 in there. So du, it will be equal to the x, and x is equal to u plus 2. Get a definite integral, do our substitutions for 1 and 3, and we get minus 1 to 1. So when we do that substitution, again, we start to see what was more complicated inside our bracket here starts to simplify. We get u to the power of 5, which is able to just expand the simpler term, which didn't become too complex with our substitution. So we get u to the power of 6, u to the power of 2, u to the power of 5, and do our integration. It's a really simple integration, and a substitution to give us 2/7. Now this question is like more of exam type questions, where we get the square root of, prove that square root of 1 minus x on 1 plus x is equal to the 1 minus x on the square root of 1 minus x squared. Now, that's not too hard if we realise that we can take our left-hand side, multiply it by the conjugate, which would be the square root of 1 minus x. So it simplifies to 1 minus x up top, and the difference of 2 squares gives us the 1 minus x squared in the bottom. That makes life a little bit easier. So those two are equal. So when we have to do our it says hence or other, when we have to do our integration of this one, we can start to go, well, let's put it as 1 minus x over 1 minus x squared. That starts to make life a little bit easier, because we can separate it then. Now, you could do a substitution if you like, and get the 1 minus x squared in there. But if we can look at this one straight away and look at 1 over the square root of 1 minus x squared, we can see that that's going to become an inverse sine function. So that's pretty cool. That makes life easy. And the x on square root of 1 minus x squared. So we've talked about this one a few times in our videos and in class, about what we do with we see that. We can see a reversal of the chain rule happening here. So it's really integrating back to 1 minus x squared to the power of a half, or the square root of 1 minus x squared. So that's the actual differentiation, is that function. So we can integrate back to that. We've got between 0 and a half here, so we put the 0 to 0.5 in our values. Make sure that's a plus there, because it went from a minus, but the integral is actually a positive. It becomes a positive. Sub in a half, sub in 0. So the inverse sine of 0, we get a 0. We get a plus 1 there, because there'll be plus 1. pi on 6 plus root 3 on 2, and then it becomes a minus 1. So there's our simplification. So you see how we're doing a little bit of work, that something looked complicated become a little bit easier, and we're able to get a situation where we're able to separate our numerator and make our terms simpler in some way, shape or form. And that's the whole idea of substitution, and being able to manipulate the algebraic expressions to make sure we can get something that looks a little bit simpler.